Vibration Analysis Introduction. Amplitude Measurement. The 4 different ways to express the vibration amplitude level are peak to peak, zero to peak, peak, root, mean square, RMS, and crest factor, average. Vibration Analysis Introduction. Peak to peak is the distance from the top of the positive peak to the bottom of the negative peak. The peak-to-peak measurement of the vibration level is shown in Figure 1. This type of measurement is most often used when referring to displacement amplitude. Zero to peak, or peak, is the measurement from the zero line to the top of the positive peak or the bottom of the negative peak. The zero to peak value of the vibration level is shown in Figure 2. This type of measurement is used to describe the vibration level from a velocity transducer or accelerometer. The root mean square, RMS, is the true measurement of the power under the curve. In Figure 3, the RMS value is the cosine of 45 degrees times peak. 0.707 multiplied by peak only applies to pure sine waves. The true RMS value is calculated by the square root of the sum of the squares of a given number of points under the curve. For example, as shown in this equation. When calculating true RMS, the crest factor and duty cycle must be considered for signals that contain pulses. The crest factor, CF, is the ratio of the peak value to the RMS value with the DC component removed. For example, as shown in this equation. A crest factor of 7 is normally required for accurate measurement of pulses. The duty cycle is the ratio of the pulse width, PW, to the pulse recurrence frequency, PRF. For example, as shown in this equation. Several forms of pseudo-RMS are used in some equipment. For example, as shown in this equation. Average. Analog meters measure average amplitude. Various constants are then used to calculate peak, peak-to-peak, or RMS. Most measurements that are not true RMS measurements are either overstated or understated. When describing the vibration level of a machine, the RMS value should be used if possible. However, some cases require peak-to-peak measurements, for example, when measuring mils of displacement. Other cases require zero-to-peak displacement measurements, such as high places on a roll. The average value is 0.637 times the peak of a sine wave. See Figure 3. Average values are measured by analog meters. Average is then converted to peak by multiplying a constant of 1.57. These calculated values are accurate only when measuring pure sinusoids. The following constants may be helpful. However, they apply to true sine waves only. The more the signal deviates from a true sine wave, the more error is introduced. Conclusions. Average is equal to 0.637 multiplied by peak. Average is equal to 0.90 multiplied by RMS. Peak to peak is equal to 2 times of peak. Peak is equal to 1.414 multiplied by RMS. Peak is equal to 1.57 multiplied by average. RMS is equal to 0.707 multiplied by peak. RMS is equal to 1.11 multiplied by average. Thank you.